So I'm Nik Everett. I work for the Wikimedia Foundation, and I spent a year and a half replacing the on-site search at the Wikimedia, all the Wikimedia wikis. Given our site traffic, many of you probably don't know that there's on-site search at the wikis, but there is, surprise. And it actually gets millions of hits a day, but it's somewhat invisible. If you go to wikipedia.org, it's there. And in fact, it's in the upper right corner of lots of pages. I might point it out to you if I remember. But I didn't actually write that part down, so I'll probably forget. Anyway, I should also tell you I'm trying something new to me. I actually wrote a blog post for this instead of slides. So at some point this will be consumable as a blog post, but that means that I'm actually going to be a little more stumbling because I've never done this before. Anyway, officially this is actually the talk I'm giving at Go to Amsterdam tomorrow. And that talk is titled We Stay On, or How We Replaced On-Site Search at Wikipedia Without Breaking Anything. And the subtitle has two lies in it. The first one is whenever an engineer, anybody, tells you that they didn't break anything, they lie. It's impossible, right? And the second one is it has the word Wikipedia in it. I only use that word because people recognize it. And that's why I have it up here. But in truth, we actually did it for all of the media wiki, or all of the Wikimedia wikis, the wikis that the Wikimedia Foundation is running on its cluster. And that's all the Wiktionaries, all Wikidata, Commons, all the Wikiquotes, Wikipedia, Wikinews, Wikisource, and all the other wikis that I don't really have the energy to say, right? In total, there are about 888 of them. The last time we checked, there's a file, just wc-l it. And there are about 265 different languages. And we had a talk at ElasticCon where we sort of went into, on a high level, like the things we did and how we did it, and the features that we like in ElasticSearch. And I was really tempted to reuse parts of the slides for this talk, but that was a 25-minute talk, and this is a 50-minute talk, and that would just not work, right? So, in fact, you can go and see it one day. There's a link in the blog post, which you can't see. But at some point, I'll put the blog post up there. Actually, I can do this. Yes! So this is actually the... See, you don't have to take my word for it. You can really go and read the talk. So, instead of talking about what I did in that talk, instead of talking about the nice features of Elasticsearch that we use, I'm going to talk about how we didn't break anything. Well, by anything, I mean much. That's going to be the focus, right? And I suspect I'm going a lot slower than I planned, so someone shout at me when I'm running out of time. Thank you. Before I go too much in, because the Elasticsearch folks are nice, and because I'm out here, and because you're here for Elasticsearch, I should tell you that first, I'm mostly going to focus on Elasticsearch things, right? But I'll be a little more general. And secondly, I've got this little section about why we chose Elasticsearch, because it makes me feel good. Anyway, so we chose Elasticsearch for a bunch of reasons. The first one is that it had an active community of users and developers. The old search, LSearchD, or Lucene Search, was written just for MediaWiki, basically just for the Wikimedia Foundation, and had only a couple of users outside the Wikimedia Foundation. The reason for that is that it was hard to set up, and that nobody else used it, right? Or it wasn't really a general tool. And that it relied on this esoteric, arcane, nigh-undocumented MediaWiki extension, and what you can't see is this red text. This red text says, someone please update the installation documentation for this plugin, because no one knows how to understand it, or how to install it. It's installed at the Wikimedia Foundation, but nobody else can do it. And so if that's a blocker for you actually having search, you're pretty much not going to get it, because no one does it, right? When I first evaluated Elasticsearch, I wrote a stupid bash script that did something that was really silly, but it actually found a bug in Elasticsearch. And I filed it, and someone at Elastic, or Elasticsearch at the time, right, they changed the name, but someone at Elastic verified that it was indeed a bug, right? I sent them a pull request, they reviewed it, and they merged it. And given that there was no community whatsoever for Lucene search, that's sort of a silly name. For this thing called ElasticSearch, this thing called Lucene search that is the custom search backend for MediaWiki, right? There was no community for that. So having a group of people that would actually say, yes, this is actually a bug, and then would review your code and get it merged was really cool. We're also really happy about automatic shard allocation in Elasticsearch. We chose that primarily because, or rather, we were really happy about it primarily because no one at the Wikimedia Foundation knew how to do shard reallocation for the old search engine, for Lucene Search, ElasticSearch. For that system, everyone had forgotten how to move the shards to different nodes, and the documentation was gone. Or it was in somebody's head, buried deeply somewhere. It was just, we had no idea, right? So it was going to be an exercise in digital archaeology to figure out how to move the shards, much less how to do it without causing downtime. We were just done, right? I mean, this is a really cool thing about Elasticsearch. That's why we were so excited about it, right? And especially coming from where we were coming from. The other thing is that Elasticsearch has these really cute tools. These aren't things that we actually decided to use Elasticsearch. We didn't decide to use Elasticsearch because of the cute tools. We didn't actually know that we needed them until we found them. Things like the Analyze API and the Cat APIs, which came actually many months after we started using Elasticsearch. And to not have them, if we had rolled our own thing around Lucene, we would have had to re-implement these things. We would have literally done exactly this stuff, but it would have been just a little different. And that would have been a huge waste of time. None of these are rocket science to implement, but there's just a pain to do it. Anyway, the last big thing about the reason we went with Elasticsearch was that at the time, Solar Cloud didn't have a way to create, didn't have the equivalent of Elasticsearch's mapping API or its analysis API. And the sort of nail in the coffin for, it's going to be hard to see. The nail in the coffin for, whatever, screw it. Nail in the coffin for Solar was that there was an HTTP GET request that you could post to Solar that would delete the index. And I pasted it to my friend on IRC and he moused over it, and his browser attempted to preview it for him and deleted his development index. We were done. We were just, no more, right? I mean, we just, right? I mean, we could have had a rule, don't paste these things to each other, friends won't paste destructive GET requests, friends, whatever. No, it was not going to happen. So, anyway, let me get back to why we actually, how we did this, my stated purpose at the talk, right? How we did this deploy without breaking much, right? We intentionally went slow and carefully. There were two of us on this project, just two people. The site handles about 30 million full-text searches a day, 130 million prefix searches a day. It's relatively substantial. And we didn't want to just like do it and break it. It'd be broken for forever and people hate us. And in fact, the requirements for the project were renders HTML, or sorry, you search the text that's in the page, not the wiki text, and it's updated pretty frequently, and no one can hate you. Those were literally the three requirements for the project. So we took that no one can hate you thing pretty seriously, right? We didn't want to just deploy garbage, right? So the first thing we did was we decided we weren't going to fork Elasticsearch. No matter what, we submitted a lot of patches to Elasticsearch. And we could have actually gone faster had we wrote some patches to Elasticsearch, open pull requests, merged them onto our local fork, and just sort of plowed ahead. But I've never written a pull request to Elasticsearch that they accepted without changes. That's okay, right? That's perfectly normal. It's very rare that I read a pull request for MediaWiki that people accept without changes anyway. So that would have been bad just on that review side, right? But then with two of us, there's no chance we could maintain a fork and do backwards compatibility. No, stop. Like that's just not, we couldn't do it, right? So it kind of gets a little better in that we are doing a lot of plugin development with Elasticsearch lately, and because we're doing plugins, we can backport certain things very carefully in our plugins. Anyway, let's skip the piece where I wax about sync flush being awesome, and then move on to the next bit. So next we had two communities that were really, really brave, and they decided that they would work with us. They were super, super excited about getting a new search, because apparently the old search was pretty good for them. One of them is Italian Wikipedia. There's one guy who's talked to us every day on IRC. And he's, an Italian Wikipedia, and he just really wanted the new search, so we were like, fine, you can have it. We didn't know what we were doing. Like, there was all kinds of broken stuff when we deployed it to Italian Wikipedia, and they told us, and we fixed it. And that was really cool. And so yeah, we broke Italian Wikipedia for a little while, but they asked for it, so I don't feel that bad, I guess. I also want to thank Catalan Wikipedia because they did the same thing, though it was slightly less active. Finally, we deployed with MediaWiki.org, which is the wiki that you go on when you want to look up how to configure your wiki. And we use MediaWiki.org all the time. It's our dog foodie wiki, right? I mean, we have several, but this is one of our dog foodie wikis. And when we break search on it, we know. And this was one of the first ones we went to, so when we did something wrong, we knew. And I'll get to it pretty soon, actually, when we did something wrong. Another thing that we did was we used this feature that some folks at the foundation wrote called beta features. The idea with beta features is that when you're logged into one of these wikis, you can go in and click preferences and then beta and then tick something like, you could say, like, I want to use the new search, or I want to see the visual editor, or something, right? So beta features was originally, here's beta features, sorry, I skipped it. Beta features was originally written for visual editor or hover cards, I think, but I kind of forget. Anyway, we were actually a really big early user of it, and a success story, because we actually kept putting wikis into beta feature and then kept making our search the primary, so we were sort of shifting through the beta features column. So it worked well. So what this means is that we had thousands of people signing up to use the new search, either because they were excited about it or because they were dreading when we cut over to the new search and they wanted to make damn sure we didn't break them. Proud for these people. So these people that did that were mostly editors and wiki gnomes. And actually, I'm not really sure that this is the right term, but I'm going to use it anyway because it's silly. It even contains so it's hard to read, but that big blue box with the upside down exclamation point is this page contains humorous material that's meant to be humorous, don't take it seriously. But in actuality, I know people that are like this. These wiki gnomes so go back a little bit. Editors are people that edit the wiki. It's just a general term we use for anyone that edits any of these wikis, Wiktionary, Wikipedia, whatever, right? Wiki gnome is a term that we use for people that make very minor edits, that clean things up. So there are some templates that you have to mark with when you decided that that template applied. Things like, there's a template that says like, the sources on this page are garbage, or something like that, right? And you have to put when you made this decision in. And so one thing that, usually it's bots, but sometimes people will go in and do this. They'll go and put the date. They'll look up the time when you made the edit, and they'll put the date in properly for you. Another thing that people do, and I love these people, is they search for spelling errors. And they adopt like a little spelling error, right? And then, they go search for this spelling error and they go and like fix it, right? So these people keep a stable of searches. And then they just go blow open all the tabs and there are all the spelling errors, and they scroll through and they say, okay, these are quotes, it's okay, it's okay, it's okay. And then they move on, right? These people are super duper sensitive to stemming, and they're sensitive to transclusions. So stemming is something you probably know what it is if you're in the ElasticSearch meetup. It's when you take a word and you kind of remove the grammary bits from it, right? You remove the trailing S or the trailing ing in English, and it gets much more complicated in other languages. But these people, people that are searching for spelling errors, well, they don't want you to do that. They want you to, they don't want you to, they're looking for the thing that they typed, right? Just that thing that they don't need to change, right? So they're sensitive to that and to this thing called transclusions. And let me see how to get this. Here you go. So to explain what transclusions are, just bring up part of the blog post. So here. No, that was wrong. Please stop. Here we go. So now it's just like semi-readable. So this text here is the actual wiki text that the page is made of. So when you go to edit a page in Wikipedia, there's this grand wealth of templates that you can use to call things out. And one of these templates here is used right here called YouTube. And it's inside the curly brackets. And it says go render a YouTube video link properly. For whatever definition of properly Wikipedia has decided is properly, right? And other places may actually embed the video or may, give like previews or something, or I don't know, right? But there are tons of these things, like millions of templates. Hundreds of thousands of templates. There's lots of them. So the trick is that when someone wants to go and fix a spelling error, if it's in a template, they want to go fix the template. They don't want to see, when they're searching, they don't want to see all the pages. They don't want to see all the text, right? All the page text, all the pages that have that spelling error, they want to go know that it's in that template over there, right? So, well, I'll get back to that. How do I, oh God, I made it horrible. Here's what a template looks like. And they can get ridiculously complicated. And they can be written in Lua. And that's kind of crazy, but they can. So, what we learned from these beta users, I started to talk about some of them wanting to search text, the page text, and some of them wanting to search templates, right? So, for example, a regular user, if your grandmother wants to search Wikipedia, God bless her, but what she wants to do is search this text right here, right? Where my shadow is. She doesn't want to search this text. But the Wikinome, or the spelling corrector, or an editor, and just editors in general, want to see this. This is what they're looking for, because this is, what they have to change, this is what they have to maintain. So, we have to give them the syntax where you can search for the text, like where you can search for the wiki text, and then the syntax where you can search for the expanded text. And to do that, let's see if Boaz renders not JSON very well. To do that, you actually have to store both of them in ElasticSearch, right? So, I'm loath to try this, but so here is where the actual text of the page starts, right? And it's this huge, massive blob of text. And here is where that other text starts. And yes, Wikipedia is a giant wall of text. It's just the way of things. The next thing we found out is that the guy that was actually complaining that he wasn't searching inside of templates, turns out that he wanted to find this page, WG namespace aliases. And he was searching for namespace aliases. Now, this text is pretty big, so you can see it, right? You see the WG capital namespace aliases, right? So it turns out that he got lucky with the old search engine because it was searching the wiki text, and the word namespace alias is in the wiki text, right? Without the WG, and so it was finding it for it, the old one. So we weren't going to do that. We weren't going to index the wiki text sometimes magically with like heuristics. It was bad, right? So instead, what we did was we automatically did splitting on camel case and snake case, Pascal case, and all the other sort of programming cases, because it turns out people paste JavaScript in these things and they want to search for JavaScript. And we're not actually that good at necessarily breaking around all of the right dots and parens and things, but we try for these goals, right? And then there was one of these spelling correction guys who wanted to search, the word for hyphens. The old search engine, you do foo-bar and foo-bar with a space, right? Those are different. Those mean a different thing. In the old search engine, if you search for foo-bar, you only get foo-bar. And if you search for foo spacebar, you get foo-bar and foo spacebar. And they did this with some analyzer hack, and it's reasonably cute and small, but at the time we couldn't deploy extensions to our cluster. We just hadn't worked it out with operations how to get extensions in there. So I said, like, look, I can't do this, right? I can't make your thing work. So we implemented this hideous, see, by the way, I lied, right? That's where I lied. I broke a feature. I broke this thing for this guy, right? So instead we tried to give him regex search. And we did it using mvel and scripts and loading the source, and it was painfully slow. Like, unless you were really, really careful, it could take minutes to complete, and by then Varnish had timed out and you were just done. You had no chance of getting the results. So, and then the cluster was busy doing these regex searches no one ever was going to get, and it was just horrible and we hated it. But the moral of the story is eventually we did learn how to deploy extensions, and the second extension we wrote was trigram accelerated regex search. So now, for the most part, these searches are tolerably fast. They're still seconds long, but you're searching a large corpus of knowledge with regexes. It's pretty good. It's tolerable and useful to this guy. But still to this day, I bet he curses me because I broke his dashes. And I don't blame him, right? I mean, these people work really hard to make the content that people want to see, right? That's why people go to Wikipedia, to see these things. So the other side of this coin, it's useless to deploy, to do this slow deployment, to do this, to get all these beta users, to collect all these use cases if you don't document them and test them. So we built a huge suite of integration tests to run on this thing. And it involves creating lots of wiki pages, waiting for them to get the search index, and searching on them, right? And that's pretty much what it does, lather, rinse, repeat thousands of times, right? And takes something like 50 minutes, and right, it's really quite important for us that we make sure not to break it, right? And so the thing that's interesting about these is, right, we built these tests into our MediaWiki extension. We built very little unit tests into it, probably because I didn't know how to build them at the time, and I just didn't feel like learning how to write MediaWiki unit tests. And also the integration tests ran on top of our plugins. They ran on top of Elasticsearch. And without that, we couldn't be sure that we weren't breaking things, right? Mocking out Elasticsearch in software that's job is to format queries to Elasticsearch, take the results and format them for the user is pretty useless, because then you just are proving anything. So what you end up doing is you end up having tests that test all the way down. So you get to have examples of this. This test over here asserts something based on Unicode normalization, and it asserts that we've set up the ICU plugin correctly to Elasticsearch, that we've set up Elasticsearch correctly, and then we've indexed all these pages correctly. So there's like many layers that we have to test. But I want that, right? I like that there are all these layers because they all have to work. And I'll get angry if they don't work, because our users will get angry if searching for this text that I can't read, which is actually 4 subtly different words in Unicode. There are 4 subtly different formatting, like layouts of the thing, that all have to be normalized together for it to work. The same is true for these tests of our highlighter, that tests the highlighter plugin that we wrote, tests Elasticsearch, tests that you can search for these things, tests that MediaWiki accepts the documents that we give it, that it sends them to Elasticsearch appropriately, and they spend a little bit of time in a job queue, and that actually gets in. There's just like tons of these things that have to happen all for it to work, right? The other thing that we did is we wrote load testing scripts. So we had to have a script that would replay the old searches logs against the new search at approximately real time with some sampling, right? We didn't want to deploy the new search and just have Elasticsearch immediately crumble under the load of the people searching in Wikipedia. So this is it, and it's probably wrong and broken, and it's all of that long, right? It's not, it's totally worth like making this thing, even if it's wrong. So what we found out was, when we were actually replaying these search logs, we found out that we could, the first time we did it, Elasticsearch could support 20% of the load, 20% of the queries that we had in production. And that's just sort of lame, right? I mean, that's not nearly enough, right? So we had to sort of attack this problem and figure out why, right? So we started out with the Hot Threads API, which is the built-in thing for Elasticsearch to tell you what's taking up lots of time. Turns out that that only gets you so far. It works quite well, but the Hot Threads API has an issue. You've probably seen it. you both, I'm pointing to you, has probably seen it, where the hot threads API determines what threads are hot, and then it takes thread snapshots of them. But in a query-heavy environment, what's going to happen is one thread is going to get a query and it's going to get hot, and then it's going to not be hot, and then the snapshot is going to come in and figure out where the stack traces are, while some other thread has gotten hot. So hot threads is going to report to you data that's like old and useless. Eventually. Hot threads is still quite useful, but realistically, to do this work, you have to hit the Elasticsearch with JStack. So what we did was we hit it with JStack, which gets you big stack traces of every thread, and then wrote a bash awk script to just sort of attempt to classify what the threads were doing, and it threw out the ones that weren't doing anything, to just guess where the expensive things were, right? And it turns out, right, that the expensive things were in the phrase suggest or the fast factor highlighter. There were some mvel bugs. In fact, here it is. Here's this mvel bug. This thing was deadly. Some of these we fixed on our own, right? We just stopped using mvel wrong. Or stopped using mvel in the way that it was advertised that it would work, but happened to work very slowly if you did it that way. Others we had to upstream, right? This is some work that we did to make the phrase suggester scoring faster. We also were using the phrase suggester incorrectly, or inefficiently, or dangerously, depending on how you look at it. And so we fixed that on our side. So some stuff we had to fix, some links didn't make it. Anyway, some stuff we had to fix on both sides. We had to push things to Elasticsearch, and then we had to use them on our side. And you know how I said we didn't fork Elasticsearch? Well, sometimes we've pushed these things into our plugins, and sometimes we pushed them to Elasticsearch and waited months for them to get released before we used them. Multiple resources was one of those. We pushed it to Elasticsearch and then waited like 3 months before we integrated it because we had to wait for a release. Because we just didn't want to. That was not possible to backport for us anyway. So the other thing that made this work is Vagrant. To run MediaWiki and to set it up in production properly is it's quite a lot of work to make it a clone of the MediaWiki production, of the Wikimedia production environment. And you really want to test the search. To test the search, you really want it to be a clone of the production environment. So there are some commands that I won't put up here. They're in the blog post, trust me, that set this up. It's actually surprisingly simple, just lots of waiting on downloads and Puppet to run. But it ends up installing an Ubuntu VM, cloning all the code, setting up Apache, installing MySQL, installing Redis, installing Elasticsearch, installing a few Elasticsearch plugins, creating a couple of wikis, and then indexing them. And then, from there, you can go run the integration test to spin up all the things, or go in and create pages on your own and validate that they get into the index correctly and all the searches correctly. But without some way to make sure that everything is set up consistently, it's just not, it wouldn't be possible to have a suite of tests. And I said those were important, so you have to believe me. So I alluded a little bit to us using plugins. We went to writing code in Elasticsearch using Elasticsearch plugins. Eventually, because it allowed us to get things in faster. Right? I told you we were waiting for Elasticsearch releases. Well, sometimes we could get away with not waiting for Elasticsearch releases. We could get away with. So we wrote our own highlighter, which is it's on the internet. You can go use it. It's on GitHub, right? With installation instructions and all that fancy stuff. And we wrote it ourselves rather than try to get it in Lucene or into Elasticsearch because it was just going to take too long. We just needed to get something done. So we got it done. We got it deployed, and it was wrong. We deployed it again, it was wrong. We deployed it again, it was right. We did that a lot, right? And to be able to do that in-house with a plugin is very important, right? And that's really where plugins shine, right? That you can do this thing quickly, right? And then there are a couple other things. Some stuff doesn't belong in Elasticsearch core. It's just too funky. The example here is our other plugin, the Swift repository. Swift is a shared file system. It's deployed at the Wikimedia Foundation and a few other places, but not many. So it doesn't make any sense to try to give that to Elasticsearch upstream. Just its plugin. If you want it, you have it. Great. We use this Search Extra plugin that we have. That's where the trigram accelerated regex search is and a few other things. We're making some efforts to make sure that to prevent users from running scary queries. and that's in there. Doesn't work fully, but it's better. And we're also making, we've also put a bunch of backports in there because we're still on 1.3, and I just made something that's going into 1.6, and eventually we'll upgrade to 1.6 and we won't need them anymore. Great, party time. But until then, we have to keep with the backports. How am I on time?
10 more minutes?
10 more minutes of talking? I don't think I actually talked for 10 more minutes, which will be perfect. So, I think I'm actually, yeah, I'm out of links, surprisingly. You opened all these hundreds of links. But, so I was going to say that there have been a few things that have been kind of a pain to work with Elasticsearch, and I should bring them up with all disclosure. The first one has actually been the MediaWiki job queue system that's been a pain more than anything. But it kind of highlights, so Elasticsearch is an asynchronous system, right? When you post documents to it, there's a refresh time, right? And your tests have to wait for that refresh to hit the system. That's okay, right, if it's a second. It's okay if you intentionally you force a refresh, which is how the Elasticsearch tests work. They always force a refresh if they've indexed the things that they want. But we couldn't do that because my tests were like 18 different layers from Elasticsearch, and it gets worse. To make this, so far as from where I stand, given my experience with Elasticsearch, all writes to Elasticsearch should go through a job queuing system. And this is really, really useful when they do, because you can do things like, you remember how I said sync flush, right? Sync flush only makes your restarts faster if you don't write to the cluster. And that's why you want a job queue, so that it can stop the writes and you just pause them. So MediaWiki already has this job queue, and the reason we used it was because at some point we deployed bad code that totally broke writes to Elasticsearch. You know how I said we had tests? We screwed that up at some point. And what happened was every wiki that we had deployed our MediaWiki extension to stack traced when the user tried to save the page. That was stupid, right? That was really bad, right? This is like, I'm ruining like hundreds of people's day. Like, I don't want to do that. So we pushed all that code off to the job queue so that if I broke it, well, it would just break on some asynchronous system and it would retry and fail, and then we'd have to deal with the failures. But at least no one would complain. And eventually they would, actually. But no one would be totally stuck. So, other reason for this job queue, right? And so it turns out, probably more so than Elasticsearch, the job queue screwed us constantly. It was constantly getting in the way. It was constantly like, well, you have to keep waiting for this thing to go through, and the tests would get all these jobs bunched up, and it's just, ugh. This one is one that, yeah. This one is one that still affects it. No, you can't see that. So the other one that still affects us is that there are some bugs that can bring down lots of nodes. And essentially the trick is that unless you're sending your search request to a single node, if someone writes a poison search request, if someone can figure out how to write a search request that poisons your system, and our system is entirely public, right? Anyone on the earth can write search requests, and we have incredibly complex syntax that they can use because our editors need this complex syntax. And it's generally actually the editors that break the system down anyway, because they're the ones trying to write some super complicated query. It makes its way into Elasticsearch and somehow eats 30 gigabytes of heap memory and takes the system down. But instead of taking down one machine, it takes down one machine per shard that received the query. And that's not good. Because I have 31 nodes, right? And if you take out 7 of them, because that's how many ways English Wikipedia is sharded, that's upsetting, right? And assuming the cluster even survives that kind of a hit, I'm getting paged regardless. This makes me angry. It's not entirely Elasticsearch, whatever. It's something that needs to be worked on. But it's hard, right? Because it's very easy to say, well, don't let users write queries that crash your cluster. Well, no shit, right? Stop them. But the problem is you're never going to know all the ways, right? If you give people, if you really limit what users can search for, if you limit them to simple query string, to term queries, then yes, you can do it. You can absolutely limit them, or if you give them only a little bit of power to do some phrases. But unfortunately, our users expect a broad range of queries that can get a little. If it ever has a wildcard in it or a regular expression, you're asking to crash, right? And so we've tried to prevent that. But I still think that it's, even if we could, even once we have a handle on all of the ways in which users can write correction queries, more will come. Because people make mistakes, right? I mean, people try hard, but you're going to make a mistake, right? And so being able to not blow up 7 of your nodes when you make a mistake, maybe it's only 1 node, would be kind of better. Anyway, the other thing that's been kind of a pain is installing plugins. I told you that I had to negotiate with operations to install plugins. That took 4 months. That's horrible. And the reason it took 4 months is because production can't have access to the internet. And by the way, every one of you should have that, right? Your production system should not have access to the internet. Never, ever. This is how you become accidental Tor routers and stuff, right? It's bad. So, not just inbound, right? This is outbound too, right? So we can't use the ElasticSearch's bin plugin thing. We can't do it at all. So we have to roll our own whatever. And unfortunately, that means pretty much everyone's got to roll their own whatever. Because, I mean, hopefully you know how to install. I mean, it's just copying jar files to the right place, but sometimes, operations, given what it is, or operations engineers, given who they are, want to make sure it goes in a way that is repeatable, it has the appropriate degree of paranoia and all of that, right? And that was especially painful for me, but I expect it's painful for lots of folks, right? And I don't have solutions to any of these problems, because if I did, I'd have solved them, right? I wouldn't be complaining. So, anyway, I kind of wandered around a lot, but I'm going to try to wrap up now and give you back a few minutes, I guess. So, looks like we have 8 ways in which we didn't break many people, which doesn't sound like it was a roaring success, but when you think about this, we replaced search on one of the largest websites in the world and didn't take it down. And we did it we just pushed a little config change, like 1 line of config change to replace it on the last wiki, and it was okay, right? We had somebody filed 1 bug. Someone that worked for us actually filed a bug and said, hey, this thing is a little different now. Please fix it. And it was like, oh, that's kind of silly, let's go fix it. And we did. That was it! And this is a huge array. I told you about these editors, these spelling people, they all have totally different workflows. And we didn't screw most of them. That feels good, actually. Anyway, the way we did it was these beta testers, right? They quickly pointed out problems, right? Phased rollout. We deployed these things wiki by wiki, right? And I think I skipped that part. But, right, remember I told you we had 888 wikis? Well, the first time we deployed it to 2. They were called test and test 2, right? And then the next time we deployed to mediawiki.org. And then the next time we deployed to, I forget. But no, they came a tiny bit later. So what we did was we deployed as a beta feature for lots of people, right? We deployed it as an option, right? And so it's actually kind of okay to just deploy things as a beta feature and not shout about them. We could actually deploy them so that the index was being built without deploying the beta feature first to people, right? So we could deploy it and make sure that the Elasticsearch cluster could actually soak all the updates. By the way, updates are kind of a thing. They're updates. Elasticsearch is great at time series data where you're just adding and adding and adding. Updates are a little bit more fun. Like we had to do things like no-op detection because MediaWiki is stupid about it, doesn't know when the documents haven't changed. Anyway, so doing these phased rollouts to wikis, to wikis, to wikis. The last wiki that we did was just 1 wiki at a time. In the beginning we were doing like 50, 50, 50, 50, and it was like nothing, like the cluster didn't care. But then in the end we were like, okay, well let's do French Wikipedia today, right? And it was, you'd get your load graphs and then they go, poof! We go, oh God, what's wrong now, right? And we go and we'd figure out why we'd made it slow. So we were going slowly, 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 and unfortunately the last pill was the largest. English Wikipedia is 50% of our search traffic. And so, there's no way to incrementally swallow that pill, right? At some point you just do it. And that was the last one in some November day, right? And the cluster, like there was this big thrash of disk I/O for about 10 seconds, and then it was gone, and it was fine. And so far it's been fine the whole time, right? Anyway, so this phased rollout was good. Canary deployments to MediaWiki.org, I told you we use that all the time. We don't use test2 all the time, unfortunately, but we do use MediaWiki.org all the time. And when search breaks on MediaWiki.org, we know. When we deploy new code, we do a rolling deploy, so it goes to MediaWiki.org first. And so if we break things there, we know this is good. Lots of integration testing, right? If I make some feature work, I better not break it again later. People would be angry. The load testing to find the hotspots, as well as the fact that we actually looked at them with hot threads and JStack. Vagrant for building as production-like environments where we can actually test. Like without Redis, doesn't work. Without all the Elasticsearch plugins, doesn't work. Without the right versions of MySQL, it's not the same, right? It's not enough like production to really do it. The plugin infrastructure of Elasticsearch was really good for us, right? Eventually, when we finally figured out how to deploy them with our operations team, it kind of took off, right? We did a lot of good things with it, and that saved us tons of disk space and tons of I/O and unblocked lots of things, right? Lots of things in the process. And then the Elastic team was super great for us, right? Not only did they make Elasticsearch, which is really useful and really great and the basis on all this stuff, but then they listened to me whine at them and actually listened and have merged 98% of my pull requests eventually. And like, this is good, right? The fact that they've been so good to work with has been super important, right? And so yeah, I'm done. See, so yeah, I guess question time. It's really hot up here.
Yeah.
It's probably really hot back there too. There are questions. I can't really see you, but I see your hand. Yes?
Yeah, great job. Are you doing anything on analytics of your logs, your views, and your edits?
Yes, this is complicated and many-faceted, and by that I mean we have many solutions and none of them really work super well together. There's a high Hadoop cluster that does one thing. There's a sampled capture of actions. So the Hive Hadoop cluster analyzes varnish logs. There's JavaScript beacons that capture things like, if you're in the upload wizard and you click browse and you click this and you click that, there's a JavaScript beacon that reports these actions. Not because we're spying on you, I mean we kind of are, but because we want to know if something breaks in your browser in the middle of something, right? And that actually gets pushed into MySQL. I don't know why, I wasn't involved. And then for our server-side logs, they go to Logstash and Kibana 3, I assume. And we use that too, right? So we have this crazy dichotomy. We have all three of these, right? The Logstash cluster does not absorb all of our logs. We don't run the logs on super duper debug mode, but it does absorb a lot. We have 3 nodes with 128 gigs of RAM, lots of disk. I think they're spinning disks. And it absorbs much of our logs and does pretty well for us. But so as one thing that's kind of cool, right? I mean, I showed you our search, right? Like, you can type foo, right? Oh, I forgot to show this to you. I'm horrible. So you can type, you can do a search, right? Like on commas, you're searching for something, right? And then, right, you can ask it to tell it the JSON that it sent to Elasticsearch. So it's just a parameter Cirrus dump query that you stick on the end of the URL, and it spits out the JSON that it dumps to Elasticsearch. It's not quite like one of the sub bits of this is what we dump to Elasticsearch. There's also the path in there and things, but we're super public about this stuff, right? You can do wikipedia.org/w API.php action equals Cirrus mapping DOM. Hey, victory, right? This is the mapping for the Elasticsearch index. We get it from Elasticsearch on the fly when you ask for it, because this is fast, right? It doesn't matter, right? There's one you can do to get the config, and there's one that you can do to get the settings that you use for Cirrus Search, which is the MediaWiki extension that does this, right? There's a whitelist to make sure we don't send you passwords, although we did that once and had to change the passwords. It was really upsetting and made me very sad. The whitelist did a sub-object, whatever. right? It was we shouldn't have done that, but we changed the passwords and it was fine. So we're very, 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 very public about this, right? I showed you something up there where you can, at the end of some article, right? I mean, I showed you this, right? That you could go into the wiki, right? And so this is the Barack Obama article, and you can't see it because you're at the back of the room, I'm sorry, but you can put the URL parameter action equals cirrus dump, and it dumps what's in Elasticsearch for this page, right? I don't know of a way in which we can be more public about how we do this stuff, right? We are nowhere near that public about the logging infrastructure, about our Logstash and Kibana, because we use PHP, and PHP has a habit of logging method parameters, and we don't have a system that is super duper good about sanitizing them. We just force people to sign an NDA and threaten them with death if they reveal this information, right? So, I mean, we're generally pretty good at not keeping PII, but this is one of the places where it ends up. So that part, right, all of our logs ain't public, and that's why, right? That's all very locked down. And so I had somebody, I did one of these talks and somebody said, oh, can you show me your Kibana? And I was like, no, I can't. That's the one thing I couldn't show them, right? So that was a long-winded answer to that question. Yes? Back in the back.
So about the asynchronous queues and feeding data into Elasticsearch. So you told it was better for you to get a message queue or a task queue, and the task queue would be indexed in document per document. Did you compare it with the size of translog per index, or instead of like having the jobs feeding asynchronously, just setting the number of transactions before the entire index will be flushed to segment?
I don't understand, I'm sorry. I'm trying to put that together.
There is one, so I discovered one of those settings when we were migrating like terabytes of data from one index to another index.
Yeah.
For the time of migration,
Yeah.
we were setting the translog size of
Yeah.
the index to be, let's say, 100,000 or 1 million.
Yeah.
And so when the number of, when there was
Oh.
transactions, it was flushing down. That's
We don't do anything with that. We don't change the translog size, we don't change the flush size. We do change it when we do a bulk load, and this is actually important that you can do this bulk load from a Elasticsearch index to another Elasticsearch index. We do a little bit of fiddling with the local index parameters, and you can look them up. It's open source, you can guys look at it. I'm not going to find it for you. But this job queue is primarily there to soak up, to take the update of Elasticsearch and move it away from users, so that we don't want users to, we want there to be a literally zero chance that if Elasticsearch is down, that edits fail, or that views fail. Literally zero, because there's no code, none of my code is in that path, right? MediaWiki is a big, monster PHP application with monster plugins everywhere, and we like to be very paranoid about how we work with it. And so making sure that my code is out of that entirely is the safest way to make sure that I never bring the site down. And I don't want to bring the site down. I've done that once. It was sad. And it's bad, right? But yeah. So that's why we use a job queue. And the other reason the job queue is useful is, you know how I showed you transclusion? You know how I showed you that there were all these templates? Well, what happens when you edit a template? All of the pages that use it have to be re-indexed. Not one, not most, all of them. Commons has millions, 20, 30 million pictures on it. Most of them are licensed CC BY. CC BY is a template. Someone changed that template. 20 million of these things ended up going, 20 million of the re-index jobs ended up going into our job queue, right? And just sort of, well, being a big, animal inside the snake, right? And then eventually, the page got re-indexed. And the job queue is actually written in such a way that it doesn't make, it spreads them out somehow, and it's actually very well written. It's kind of amazing. But it's also really funky to work with. But in any case, right, that's why we're using it. Sorry.
And how do you handle when a re-indexing fails in the middle?
We just retry it on the job queue, and then eventually, if it fails too badly, so every time it fails, we log an exception, right? It gets logged, right? And if it fails, and then fails, and then fails, and then fails, and then fails, then the job is thrown. And then we have a script that we can run manually that goes in. We have two scripts. One that goes in and just crams the wiki into the system, right? We can give it an edit range, and it can cram it in based on edit range, but it's super slow because the MySQL query that uses the date range is really slow and horrible. Or you can give it IDs, and that's really important because PHP leaks memory like a sieve, and if you told it to index all of English Wikipedia, it would die. So instead, you run that command in such a way that it spits out all these ID ranges, and you run that through awk to make the command again that you can then run over and over again. And in fact, what that command, all that command does is enqueue jobs that are then picked up to do it. But you still couldn't do the whole thing because of the memory leak thing. And anyway, so that's how we handle outages. We also have another script that goes and looks at the Elasticsearch index and looks at the database and it goes, yeah, close enough, right? Or then it looks and it goes, what the fuck? And it just queues appropriate commands to rebuild the index as possible. This is required if there's a Redis outage. So Redis is the job queue maintenance system, right? I mean, Redis is in general a data structure server, right? But one of the data structures that we keep in there is the job queue. And if Redis is gone when a user makes a change, the job is just, we can't do anything, right? We just have to throw them on the ground. We log messages and people are on fire and they're running around and they're trying to bring it back up. And this is like a super duper important thing for us, right? But we're still going to lose some if we do that, right? So we have to have a script that goes in and picks these up. And it has to be reasonably quick because it has to walk the whole wiki, right? It has to walk the 4 million content pages with the 16 million other pages, right? The talk pages and templates and user pages and da-da-da-da-da-da. It has to walk through them all and make sure that they're all indexed. And yeah, all this is, it's not just the articles that are indexed, right? It's the articles and the user pages and the users' site JavaScripts and whatever. Next, please.
Yeah, I was wondering if, since you're doing all this complex transformation, if you tried Spark in combination with Elasticsearch to create new indexes for specific transformation like templates.
So, no, and the reason for that is that there is no spec for MediaWiki templates. MediaWiki templates, well, there is a spec for wiki text, right? Let me bring this up to you, right? So you would think that rendering wikis is easy, but that would be very wrong, and that would assume that you'd only spent about 20 minutes thinking about how to do it, and then when you actually looked at how it works on Wikipedia, you would just be done. You would be cooked. And this is actually how the old system, what in the world did I just do? Attention, here it is, here's the box. So here's where the wiki text is, because why would you not take it into the whole page, guys? I'm losing left side as I go. So here's the wiki text, right? And it's reasonably easy to write a parser that says, oh, square bracket, Honolulu, square bracket is a link. This is easy. Like you do this, you assign this problem to, like maybe college students taking their first Perl class, right? But it gets more complicated where, well, what do I do with this? Barack Obama sidebar. Right? This is a template. He has to resolve the template, right? You can only do that by interacting with MediaWiki's database, right? You can only do that by interacting. Well, okay. Well, say you do figure out how to read MediaWiki's database, and you do get to do that, and then you do get to look at the square brackets. Well, good for you, right? Some of these templates are written in embedded Lua that wants to interact with MediaWiki's specific environments, with specific plugins written to MediaWiki that are only enabled in English Wikipedia. And by the way, if you go to Commons, there are different plugins enabled. So the only chance we have of getting the right text is by asking MediaWiki to render it. And the only convenient system to do that is MediaWiki, right? We can either use the API servers or we can use the job queue. And using the API servers is somewhat unconscionable because those are for bots. Those are for people that want to fix the wiki. Those are for people that need to do data mining externally to us, right? We have a system for doing these delayed transactions. we have a system for doing these transformations. It's called MediaWiki. We have the delay transactions that are, right, this job queue. So like this is we didn't go to something like Spark because we already had all the pieces there, and because there was no way that we could farm this out without just spinning up more MediaWikis, more PHP processes, more PHP processes. We need a lot of them. Was that?
I guess I somehow understand it.
Sorry.
Okay. Last question.
Yes.
So, are you still afraid that you might have broken search anyway? I mean,
Sorry?
are you afraid that you might have broken search anyway? So, from your story, it sounds like you catered really for the editors and the wiki gnomes who care about this little hack here.
Yeah.
The on-site Wikipedia search that I know is, well, like any other on-site search, perhaps, like the Google site Wikipedia.
Yeah.
Otherwise, that would be fine.
Yes. So this is the thing, right? I mean, for the most part, the way we did this is by beta testing with users and by asking them whether it's better or not. And we got the answer pretty much that yes, it's better, right? There are a few things that are left that are non-obvious, that are obvious that we haven't done. Things like phrase matches that are out of order. We haven't done things like optimizing the relative weight of title text to page text to the subtitles under images to the headings. Those have different relative weights, right?
So, how do you know if those weights that you said?
We don't. And the only way that you're ever going to do that is by building a system where you measure user perceived relevance, and to do that you have to actually look at how the users are interacting with your system, log it, do a bunch of analytics on it, and that's something that we're actually building now, right? Is where we see to this, we see. So I have an analytics engineer who did lots of research and on open document on papers and things to try to find how you measure this and how you build this thing. And ultimately the goal is to build a feedback loop where you can sort of self-optimize the thing. But that's further than just have a graph of how well you're doing, right? So you can deploy new things and know like, oh, that made it better, or that made it worse. So then you could actually tweak these parameters and actually just check, right? You could do it manually, and that might even be okay for a little while. But yeah, I know it's not good, right? So yeah, this is a hard problem, but this is not a problem for two people, right? Remember, all this stuff was a two-man project, right? Two people are not going to do the feedback loop optimization, the various degrees of analytics that's required, right? The team that's spinning up for that is like 15, and that's actually pretty meager for some of this work. So my answer is yeah, it's really hard, man. And no, we're not really sure that we didn't make it worse in all ways, but nobody complained. And for two people, that's the best we were really going to get. And that was the last question.
That's it.